Maybe a bit more dramatic than needed, but at least, everybody is back. Hello, Gilad, you never move. You're always here. It's unbelievable. Fantastic. And hello, everyone else. Welcome, everyone, to this wonderful adventure of ours. It seems like you are really running out of time to explore the wonderful, magical world of complex UIs and AI. It's so strange that so many people actually showed up. Don't you have enough AI in your life? And don't you have enough complexity in your life? You want more of it? If anything, this is a little bit worrying, maybe. So there must be some good reasons why you ended up signing up here for this. And obviously, because we probably will be diving quite a bit into the notion of complex UIs and what to do with AI as well at this point. And just raise of hands, if that's okay. Not raise of hands, raise of cities, I think at this point would be always fun. Could you just write in the chat what city you are connecting from today? San Jose, Chicago, Costa Rica, wow, Porto, Seattle, Pittsburgh. Oh, fantastic. Wow, look at
Hello.
them. Hello, hello. Couple of people. Oh, hello. Hello, Lucas. As well. It's like bringing up memories. Week, wonderful to see you back as well. You don't change. Hmm. You try not to, at least. Right? Birmingham, Alabama, or Munich, fantastic. So, again, it's absolutely incredible to have you all here. Fantastic. So, welcome, everyone, or maybe welcome back. Now, here's a question that I do have to ask at this point. Has anybody attended a smashing workshop of sorts before? If you did, please write a plus in the chat. If you did not, please write a minus or any other symbol that would be discernible in some way. Minus, plus, minus. Oh, this is very confusing. It's like first timers. Excellent. A lot of people and more people are storming in. I mean, this is Thursday. You can do so many cool things Thursday night, and you choose this, or maybe Thursday morning. That's a separate story. Anyway, excellent. So if you already attended, so excellent, welcome. Oh, thank you so much, Lucas. This is very kind of you as well. From my end, the one thing that I want to mention is to explain how this works. The rules are very simple. We have a Google Doc. That's like something you have to tattoo on your chest somewhere. We have a Google Doc. That Google Doc is everything you need in life and maybe even more. It's like your digital passport of sorts, at least in my world of complex UIs and AI as well. There's a lot of stuff here. First of all, there are, of course, really interesting and insightful workshops that are coming up. I'm actually going to run one on legacy UX if you're spending a lot of your time fighting or embracing legacy in some way, that might be something for you. Also, like with a friendly discount for the next 2 days. And then there's another one which is all in, like a really deep dive into enterprise UX patterns. So that's maybe for you as well. And then we have also AI stuff as well. So feel free to jump in there. But beyond that, there are also slides. And there are a lot of slides. And I'm not joking, actually. I think I maybe stretch it a little bit too far at this point. Because if I look at what I had in mind for today, okay, that's actually quite small. 464, but it used to be something like 1,000 plus. But I think you get all of them, which should be. Okay, actually, I was thinking it's a bit more, but that's okay. Here we go. You get the slides. There will also be a video recording. Everything is being recorded as long as there is a record button that I have hit. Yes, the record button is working, so that's good. So you will be seeing the video recording appearing over here. You also will get an email on that as well. Beyond that, there are some useful resources. These are basically my bookmarks that I rely upon. This is something that we developed as AI solution canvas for any kind of AI products. So feel free to use it if you like later as well. This is very helpful. Maybe we'll dive into this in the Q&A later today. But then also a lot of things about systems thinking, about the state of AI. Oh, that repeats itself, so I can actually delete this here. Then this notion of AI explainability that's coming up in terms of compliance because we need to label and signal AI if it's AI. Then there is, of course, context engineering. With that, also harness engineering. This is a new thing that started showing up since February this year. And then a design workflow, a lot of stuff on that and more stuff, like also complexity and all of that. So the point is not to go for all of these links, right? But I will be pointing out, or I'll be showing certain things, and you will always find whatever it is that I'm mentioning here in slides or here in the doc. But I do encourage you to take notes. Because if you think that there are certain things that could be applied or applicable, useful for your project or your product, please do take notes because it might be a bit difficult, as it proved to be difficult in the past, to refine those things later because there's just a lot of stuff. So please do take notes. Okay. Excellent, Jamie, no problem. So if you are looking for the Google Doc, the Google Docs, the shortener is smashed.by AI complex. because complex AI was taken for some reason. Well, I can twist and bend things, but here we go. I just pasted the link in the Google, in our Zoom chat. So feel free to open it there. Okay. So with this, I think we have most people who wanted to join already here. So I don't want to waste any more of your time. So let's just jump in and go ahead and explore what to do with all of this. And hold on, let me just make sure I actually show this. There we go. And as we are diving into this world of complexity and AI, I need to explain to you where I'm coming to this. Now, hello, my name is Vitaly, and I think for the last, 15, 16 years, I've been spending quite a bit of time in really sad worlds. They're no fun in my world at all, because most of the time it's corporate, it's enterprise. I'm dealing quite a bit with legacy, I'm dealing quite a lot with migrations, also especially in the times of AI now, with a lot of challenges that many companies have because of the data that they have and the quality of data that they have. So they launch AI features, they just don't work, not only in terms of adoption, but also in terms of quality of the output that they're producing. And my job is to try to find out why and find a way to make it better. That's sort of what it has become. In many ways, trying to, I guess, minimize confusion, frustrations, and anything that's really confusing, and bring me more clarity into this. And so when I look into AI and when I look into design and when I look into UX, I don't look at it from the perspective of what we usually think of in terms of UX. Like for me personally, and I don't know, please write in the chat plus if that's the same for you. A lot of articles we see online about UX, about design process, about strategies and guidelines and patterns, they just don't apply to me. They just don't apply at all because I happen to be in a world where I have remarkable restrictions, not in terms of actually talking to users, but also just a lot of legacy and complexity and the domain I have no idea about, and it's really difficult to navigate that space. So I find it remarkably difficult to learn anything anyway, because also a lot of those projects are under NDA, so they're not publicly revealed or something. You will not get access to any metrics or anything of that sort. And so I'm really trying to find anything that would be meaningful to me. And this is something that I try to bring into workshops like this as well. And so what today I want to do with you is to highlight things that I learned, basically. Not, I have to be really perfectly honest. It's not like I worked on all of that and I use all of that or anything like that. But this is what seems to be working better to people compared to what doesn't work at all in environments in which we happen to be. Now, if I could you please write in the chat just what kind of industry are you coming from? You might be living in any of these environments. You might be working on something like, healthcare or insurance. Or I can see Anna already from insurance. You might be working in banking, maybe ERP systems. This is like one of the recent projects I was working on. Dashboards, right? Maybe something that's extremely specific, like financial sector, financial analysis, power grid management, modeling, visualization, fintech, dashboards, healthcare. Oh, excellent. Real estate and health tech. Incredible. So in law, well, that's fantastic. So I think I have something for you. Actually, Wick, this is interesting. Oh, this is interesting. Really, I had no idea. So this changes everything. Of course, B2B, right? All of this makes perfect sense to me. And so when I look at all of those things here, they are difficult, but they're difficult in very different ways. Because when we look into what they represent, actually, they represent complexity from a certain perspective. And this is how we usually think about it. It's kind of a very restricted domain. It's a domain that often requires training. You cannot just jump into this project. All it also means that if you jump in this project and you have no background in law or in ERP planning or anything like that, you will have a very hard time getting anywhere. This is what it feels like to me. But I try to still make progress, right? And so how do we do that? Well, if we abstract away from this, right, and if you think about just a good representation of this sort of environment, I cannot think of a better example than this. Now, you did not see this coming, I think. This is the best example I could find. This is going to be the spirit of what we're going to go through today. So no fun. I promise you, no fun at all. Because when I look at it here, now, what is this, by the way? That's definitely not fintech, is it? I don't think it's fintech. Doesn't look like it. No cavities. Ah, that's funny there. I like that. Yes. A dentist. Very good. I live in Berlin, by the way. I didn't introduce myself properly. And I think I switched now 5 or 6 different dentists because I don't trust the applications. When I look at the application that they're using, I feel like this is no way. And I don't have like a particular problem with my teeth, I think, at least. But no way, I'm not going to trust those dentists with those applications that were built in somewhere in 1990s, where they cannot even hit buttons properly. That's not going to work. Oh, this is interesting, Kate. I will definitely look into it. I think I should be building a club of dentist application lovers. Dentio sounds like a really good fun. Anyway, but when we look at this here, what we basically get to see is indeed an application not for dentists, but for people who aspire to become dentists. Because this is something like a dentist exam application. And of course, with that along, you have a situation that could be a patient record, right? And we have teeth, right? And as we look at these teeth here, right, each of them have different markers, right? Some markers are red. What does it mean? They're just different. So some of them are red, some of them are white, some of them are black. And then you have this orange line in between of sorts. Falling, cavities, maybe. Frankly, I have no idea, but I'm just curious what you think here. Bleeding. No, the bleeding will be represented like this, actually. Right? But what you will find in this sort of application, this is why I'm asking, oh, this is like really going very specific, like maybe we do have dentists here in the house. This is quite impressive. But this represents a vocabulary that is being shared by people who are using it. They need to learn it. It's not a particularly difficult one maybe here. You just have a couple of colors that represent different things, but you have to learn it. From us coming from outside, it's very difficult to understand what is what, except from the fact that maybe the red one means exception or not good of some sorts. But the rest is not necessarily obvious, right? And then we also have these outlines and they all represent different things. So this is a domain. Now in that domain, what we have is a lot of data, like 1x, 2e, 3c, and so on. All of these are huge, like a lot of different data points. And of course, you can, if you like, you can drill down in any of them. I really worked very hard on this. You see, drill down. It's supposed to be funny. Okay. One love. Great, this is going great. Excellent. Yes, so in fact, you can drill down in any of these sections here and you can explore more if you like. I think maybe more smiles coming in. You can explore that in more detail, right? And you can also navigate, switch the view, maybe to a table view, maybe to a chart view, maybe to a dashboard view or anything like that. And then you have the editing mode over here. And they also have widgets and stuff like that. And of course, mandatory, a calendar. Every single enterprise application of that kind needs a calendar because what's the life without a calendar? So that's one. But then if I look at another one, maybe from fintech, it makes no difference to me. Perfectly honest, this looks very much like this, just different domain. Now, for example, I think it's really worth noting at this point that we do have the same situation, basically. We have a lot of data, maybe way more data points here. But you can also drill down here and explore something in a bit more detail. We have this little thing over here that actually gives us a way, I think it was somewhere. We could actually say, I want to explore only 1 month or 2 months or 3 months or something like that. Plus, on top of that, you have different tools, right? That you also have vocabulary that needs to be learned. If you already learned it once, you will know exactly what it means. Because here, these sort of experiences, they have patterns. So if you're a financial trader and you're an active trader, then a swing trader or something like that, you will know that what that means for you. You will know what this means to you. You will know what these lines mean to you. You will know OHLC, which is opening, highest, lowest, and closing. You'll be very familiar with this. Right? This is not a big science over here, right? And of course, because it's an enterprise application, you need to have a calendar because no product can be without a calendar. That's just unapplicable, right? But then, of course, if we start diving in, of course, it can get way more complicated than this. Because when we look at this, we look at just one screen, right? Just one screen. And again, at this point, you might be thinking, where am I going with this? Well, if we want to bring in AI in some way, or we want to make better sense to create better digital products, better digital complex products, better complex digital products, I guess is better. But then we kind of need to know what we're doing. And we need to understand how to deal with this in order not to disrupt existing behaviors, existing mental models, and really tap into them with or without AI, right? However, what I think is really important to understand here is that I always need to not just look at the screen because it doesn't give me enough insights. I need to abstract away and zoom out. Because what is interesting to me, the very first question that I would be asking, not only to, I basically go to people and ask, how do you use this product? Where does it serve your purpose? How do you use it every day? Do you use it 5 hours a day, 1 hour a day, 1 minute a day? Like, what is it like? But more importantly, in which context are you using it? Ironically, this is exactly what then is going in a lot of detail in the context engineering part that we need to bring in with AI. So this will be the connection. So it's just going to take a while for us to get there, right? So what I want to know is not what it looks like, but what it looks like in the context of a user using it. Because this is another application which is like looks like a terminal in a Bloomberg terminal. And in fact, you will find that this is just, seems like a really busy screen. Well, this is nothing because most of the time, those traders, professionals who usually go through training to get here, will be using 4 of those at the same time. Sometimes with multiple screens representing multiple views of the same application. So what you see in front of you here is not 4 screens, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 screens. And they do so daily, right? How many screens do you have? Anybody have 18 screens? That's a lot of screens, I would say. I don't expect that. Not Danilo. Well, we'll see about that. Maybe this is going to change. You're just going to Amazon as this moment, right? So with this then, what we need to understand also is how people are using it. And so you would say, we always come with these prejudices, or we always come with the stereotypes. We always think, people with, ties and financial people and serious people, the New York Stock State Exchange kind of people. No, not at all. That's a user of that application using it daily. So we shouldn't be forgetting and we shouldn't be kind of exaggerating it just because we believe in something, right? And again, just to make it very clear, very often these setups are remarkably, well, painful to us, but also very complicated, and they need it. The worst thing you can do as a designer is to come in and say, I know what to do, I'm going to simplify it. No, the worst thing you can do is to oversimplify this environment because this is working for them. They've been doing this for years and years and years. If you come in, usually, and this is kind of how I feel, I'm being perceived most of the time. Usually when I come in, I'm being perceived as a very strange and very suspicious person. Because I'm coming in as a designer, and designers have, of course, opinions, but most of the time designers just change things. Nobody likes to change things. If I walk in your room or I walk in your workspace and say, I know, I've been training this, I can do, design, be digital or whatever, I'm going to clean up your space so you're going to work better. You will look at me and say, good luck, I don't want to see you again, right? This is at least the experience that I often get because I'm being perceived as a disruptor, as somebody who's changing things without clear reason why. And that's supposed to help, but in the end really breaks things along the way, especially when operating on legacy, which is kind of a separate topic on its own, right? So that means that we need to be extremely careful with anything of that kind, because this world is very different, because this world is very difficult to twist around. It's really almost like one of those wicked problems that we have to deal with. Why? Well, first of all, because usually it's inherently complex and it's designed for experts in that domain. Like, for example, I was working with a power grid company in Netherlands, which is called Alianda, and they were showing me interfaces. I had no idea what the hell is going on because they need to understand the gas dynamics and the flow of electricity and the physics in order to be able to use it, but also in order to be able to design it. So designers who are working there in the team, they go through extensive training from 6 to 9 months to understand physics before they start designing, with physics in mind, right? So good luck understanding that within a couple of months or so. This is just extremely complicated. But if you're designing for those experts, you kind of need to know what you're doing. But what's more problematic is that a lot of things that we're again talking about, like the customer journey maps, the user journey maps, they just don't apply to me at all. Just don't apply at all. Because many of those flows, or workflows, I should say, they're just non-linear. There are many different points of entry. People just jump in somewhere and they explore, and then they jump again. It's not like a checkout where you start with a shopping cart and then you all go all the way to the checkout, through the checkout, and you're done, right? It's not quite like that because you just jump somewhere. And I'll show you an example in a moment, right? But this is very common in my world. There is no starting point. There are many, many, many dozens and hundreds of starting points. And then steep learning curve. Often those products are things that people cannot choose, especially if you're working in healthcare. For example, you probably will be familiar with it. You're working maybe in law as well. You just cannot choose what you're using because this has been procured. And so you're going through this and you're going to use what is being used. Oh, yeah, right? That's it. You also have intense usage rates, 8 plus or 6 plus or 5 plus hours a day. And we shouldn't underestimate it. If somebody is using a product for just 5 hours, they will already know the product fairly well. If they're using a product for 5 hours a day for a year, oh, they will not see all the inconsistencies, all those things, because they will have found workarounds to make things work for them, right? So we shouldn't be underestimating it. This makes UI on its own less relevant over time, as long as somebody is successful. This is why people also get stuck with pretty horribly looking products to us when they look maybe horrible to us because they work for them. And then on top of that, you have a ton of customization, not only custom features maybe that are built for that company, but also custom presets that a person has set up, maybe keyboard shortcuts that allow them to navigate faster, things like that. Along with it, because it's usually a relatively complex domain and they don't use all of those features, there are some so-called zombie features, which are things that people basically never used, never tried, never know why they're there. They also have weird names and nobody dares to click them at any point of their life because they just don't understand what they represent. There might be quite a few of them depending on, again, the type of task that the person is performing. And along with it, you also have this whole mess with legacy, where you have a lot of fragility because of dependencies you have, third-party systems you have, many unknowns, like those legacy boxes are literally black boxes. You have no idea what's going on there. And if on top of that, you also have stressful high-stake situations, which are called like the VUCA situation or VUCA environments, volatile, uncertain, ambiguous, and also complex, then you are in a really difficult situation, right? And so my job then again is to maximize clarity and minimize mistakes. And what I want to spend the rest of the day for us today, session today, so is looking at how we would actually do that in this sort of environment. Now, before I proceed, does this environment seem more accurate to what you're going through every day or less? Could you probably write plus if that's you or minus if it's not you? Danilo, not yet. Well, once you have 18 screens, it might be different. Right, so maybe not all of you, so that's good, that's fine. But just to give you a bit of a context of where I tend to live, right? Okay, so with all of this, let's just see how we're going to tame the beast. And when I'm talking about taming the beast, I'm not talking about reducing complexity because you can't reduce it. The only thing you can do is to manage it more or less properly. Because one of the types of products that you kind of can be thinking of here, oh, hello, Krish, wonderful to see you here as well, is to maybe look into something like this. This is a very specific product that is more like for 3D modeling, right? Where you can actually define geometry, you can define the physics, you can find rules of physics, and then you can go and see what is going to happen given certain conditions to play out and forecast what is likely to happen, what is less likely to happen. There is no single entry point except from maybe setting up a geometry, but then once it's set up, you just explore, right? You're just out there exploring. Now, in this sort of environment, what is really important, I think, to understand is that if all of those things that we have here, not everything is always used. Because pretty much every product is like a city. And what I mean by that is that, if you look at the city, very often you will find people going through, the central hubs of a city, right? They're going through all the central hubs in order to get to job, in order to get to kindergarten, in order to get to a supermarket or just traveling, right? Whatever, right? They live in a different area maybe, but they often go through these hubs. If you want to make the city better, to work better for a lot of people, you probably want to invest time and effort into redesigning that hub or those hubs that people are going through. There might be also some small hubs within each district that somebody is living, right? But very often, those are the things that you might want to improve. Why am I talking about this here? Because if you look at complex systems, they're very much like a city. They have a lot of intertwined requirements, complex infrastructure, things that are deeply connected. shortcuts people taking, shortcuts that exist, but people bend and tweak them in some way. Little things, little weird things where, for example, there might be a required input field somewhere. People know that it doesn't matter, so they always, for the last year or two, have been typing the same thing as a placeholder just to pass that required field. Those things, right? People are really good at those shortcuts, but then also chaotic behaviors and a lot of snowflakes, right? If you want to make a difference, you're looking at where people spend most of the time, which features, which workflows, which parts of the experience are most commonly used or more frequent, right? If you just clean up the UI, it's not going to do anything. If you just make things a bit more consistent, that's not going to make any difference at all. Because again, people are using this for 5 to 8 hours a day. They don't even notice those inconsistencies anymore. Think about the button. Can you think about the button, everyone? A good button, like a really nice button that you maybe designed one day. At some point, once you've designed enough buttons, you are that button. You know that button in and out. That button is you and you are that button. It's very similar to that product that somebody is using. If they have a particular workflow that they're using for a while, they are that workflow. That's all there is. There is nothing else. That's only that part. They know it inside out, so they don't even notice the inconsistencies that it might have. And if we break it, well, we break a neatly orchestrated way of working. So what do we do then? Well, if every product is like a city, if we want to improve the city, we go in the hubs. If we want to improve the product, we go in where people spend most of the time and effort. That, however, requires us to understand what people are going through. So I always use this little framework here to guide my decisions, I guess. And I mean, it's very simple, but I think in many ways this is very accurate. Because what we have here is, as designers, we're navigating between three different areas. We're navigating between reality, problem space, and solution space. That's not surprising, no surprises here. But the reality is often very complex, contradictory, evolving, and not fully knowable. So we try to understand it in some way, and we try to map it in some way into the world that we can understand. So we're creating customer journey maps or things like that to be mapping that reality into the problem space. This is also where we try to understand the domain, observe behavior if we have access to users, explore user needs and stuff like that. And then once we know enough, or we think we know enough, we move to solutions. And this is where we're really good at. I mean, after 20, 30 years of doing this, we are pretty good at this, I think, especially on the UI level over here. But the important part is that this translation between reality and problem space is really critical, because otherwise we just end up creating solutions for problems that don't really exist. And for me, the crucial part is to spend just enough time in here, not too much, but just enough to start feeling comfortable and confident about that space and that domain, and also have people near me who I can always ask if I don't understand something, right? So I really try to spend enough time in this. And I'll show an example in just a moment. But as you try to map it out and try to understand this, you will probably see that you will be facing significant challenges. One of them is the way of how you are working. That might be a more real representation about your workflow every single day, more or less, because there are pressure coming to you almost every other minute or so, where maybe there are dependencies, maybe we need to do something, maybe there is context switching, maybe we need to bring more people, maybe we need to be faster, maybe we need to be slow, maybe there is AI and anything like that. This is kind of a real world. But on the level of that domain, one thing that was really mind-shifting for me is to really think about this particular problem space in a very different way. Usually I think, well, I just need to find a big enough user need, like a big enough problem right here, and then focus on that. That doesn't work. It doesn't work because in a lot of complex environments, you're not looking for one user need. You're looking for the system. Because you might have some things or something that actually causes trouble for users. So you fix it and then you're done. But a lot of scenarios have much more that is actually slowing people down, that is frustrating people, that they cannot make progress on, because there is not a root cause of a problem. There is a root system of a problem. If you just change one of those branches, it's not going to make any difference, right? And so this brings us, of course, depending on the situation in which you happen to be, to this notion of how do we even find this root system? And this is, of course, the point of systems thinking. And I don't want to go into too much detail into that, but some of you might have heard or might have used this iceberg model for system thinking, and there are many, many, many others as well. Basically, a way to understand the complexities of the real world and apply them. I mean, this is a separate topic, and I also put in links to books that I would highly recommend for system thinking in the Google Doc. But this would actually go a little bit too far, maybe. But what I do want to show is that most of the time, those complexities need to be represented visually, maybe like this, right? So you have things that are really influencing each other. And I'm not saying that every single project of that kind should create something like this, but this is sort of one of the fields that you will find in system thinking, where you have different areas that affect each other and in positive way or in negative way, right? And this could be even like if you think about like, policies and ecosystems and stuff like that would then be represented like this. Those little, again, this is just a different domain here that we need to understand. There are indirect connections, direct connections, there are delays over here, and there are all these connections that we usually need to visualize first, right? But that would be sort of the spirit of more complex environments. So, okay, where am I going with this? Well, let's take a look at an example. This is GexCon. GexCon is a software, 3D modeling software for professional experts who are supposed to be able to track and analyze and study gas dynamics to understand what about situations like fire explosions and anything of that kind that could happen. Along with it come, of course, a lot of different settings that they produce. So, for example, there's a geometry, so you can set up geometry of the space. You can play out different scenarios. You can define a grid and how it's going to interact within a factory or machines that you have and stuff like that. And then you have a solver. Frankly, I don't even know what that is specifically. And then you have the results of that animation, of that experiment that you're running here to see how things are playing out, right? Now, back in the day, this looked like this. Nice, right? Do you feel any difference between this and this? Right? It's like almost the same thing, more or less, right? So this used to be like that. And then you need to flip it and turn it upside down to make it a bit more usable, maybe, in some way. Well, oh, Kate loves consoles. Who doesn't love consoles, Kate? Here we go. So what is it that's in front of us? In front of us is a 3D simulation software that is used by engineers to model fires and explosion. Specifically, not just by any engineers, but CFD engineers or safety analysts or process engineers, as they would be called. In that modeling software, there are 1,000 or actually 1,000s of highly interdependent parameters. And like in every other software, there are two different types of complexity that you're managing. Alyssa, there is a smash.by complex AI or something. If somebody could paste in the link to the Google Doc, that would be great. Oh, thank you so much. Right, so there are always two levels of complexity. And this is coming from a book from 1967, I believe, 1977 or so, around complexity, which I will have to refine. Okay, later. Well, which basically highlighting that there are actually two different levels. One of them is essential and one of them is accidental. When we think about essential complexity, that's a complexity you should not break. So, for example, in this context, it's scientific logic that is required for accuracy, or in other words, physics. You can't simplify physics just to say, well, we're just going to simplify the product here. You need to match the complexity of physics. It's absolutely critical to get right. But along with it, there is also a good enough notion of accidental complexity. And with accidental complexity, we actually have a lot of friction that has been caused by just bad design, technical debt, any inconsistencies that have been produced and have been used, any poor decisions and judgment by people in the company, right? And in this particular case, this was a software that was designed 15 years ago and built 15 years ago. So no question that there was a lot of legacy that has been accumulating. And I think that there is one thing that I really need to mention here. I'm always getting confused because people often assume that legacy is bad. I don't think that this is accurate representation of legacy at all. Because legacy products, unlike many other products, are extremely successful products. It's extremely successful software. If you have legacy that's been around for 15 years, it means it works really well. It worked at least really, really well. Good luck finding software that can actually still be around and work around for like 15 freaking years. So this is a very successful software that just happens to be outdated. So you don't need to replace it. You need to modernize it. This is why we usually talk not about retiring legacy, but modernizing legacy. Sometimes you need to replace because there is no other way, and we can speak about it separately. But I'm just very confused. Legacy is very successful products. We should not be forgetting that, right? So you can't just remove them. Then you're just removing the heart of everything. So basically, here, the point was also not to replace, not to retire, but modernize that legacy system for experts and also two other goals, which is support high-speed expert workflows and also create a clearer learning path for new engineers to be onboarded. Okay, again, I just want to remind us that this was the beginning, right? So I know this looks very inspiring, but how do you actually make progress here? Now remember, every product is like a city, so we need to study that city. And so this was the process. This is a wonderful case study that was produced by Creative Navy. This is a digital agency from the UK. I think it's 14 or 15 people, and they spend most of the time in this sort of complex world. In the Google Doc, you will also find a link to the case study of them. That's seriously impressive. And this was the process, and this was the whole project. So it all starts with 4 weeks of research, understanding user needs, understanding domain, speaking to stakeholders, stuff like that. Then trying to figure out the scoping and just trying to explore a problem space or kind of moving closer to the solution space. So we understand the key UX challenges. We try to understand what people are doing here, requirements mapping and other things. And then execution, 7 months. So they actually managed to pull it off within less than 9 months, which is quite impressive, I have to say, right? So, and then this is where you have the design system and all the good stuff here. Okay, so where do we start? Well, we start by looking at this very carefully and trying to understand what the hell is this. My first step would always be just talk to as many people as I can to find out just what people actually do here. What are some of the frequent tasks or jobs that they're doing here? How often do they use the software? Similar to what I was showing in the beginning. And also, what are they using aside of this software? Are they using any other products, any other services, any other software along with it, where they need to copy paste things and so on and so forth? And this is usually the two different sides of the equation to understand the software, but also how exactly it actually fits in somebody else's work. Also, just to quickly step out for a second here, I put up a little article over here, which kind of describes the process that I'm following. So maybe that will be helpful for you later as well, which basically highlights how exactly that actually works. Oops, sorry. How exactly that works. And specifically, it all starts with trying to understand what is it that we have in front of us. There are two types of analysis that is usually very worth doing. One of them is task analysis, the other is workflow analysis. With task analysis, we try to understand how and why users complete the tasks, basically what they do. But workflow is more about how they collaborate with other people or other systems to basically be successful, right? These are different sides of it. Sometimes also this, but this is usually part of task analysis to me. So I need to understand how people actually work through those tasks and what the goals that they have are, and how they're working together to reach a shared goal, especially when their part is maybe just a small part of a much bigger goal that they have in front of them. So one is task analysis, the other is workflow analysis. Does it make sense, everyone? Anybody else sleep by now at this point? Or they will never reply, I believe. Christine is not asleep, so that's good. All right, so let's see how to make progress here. So that means we go in and we start off by learning the domain, by trying to understand the problem space enough, right? I'm never getting something like 5 or 10 months of research. That's just not happening, right? But okay, so maybe you could be still asleep. I could be already whatever week. As long as you're around, that's okay. So we try to understand the problem space a little bit more, right? And actually map reality into problem space. So we understand the domain, maybe some internal training videos. Maybe we try to understand again top task analysis and workflow analysis, right? Interviewing people. And in fact, in that particular project, 24 user interviews, 23 working observations. Oh, how are they different, by the way? What is the difference between user interviews and working observations?
In user observation, you can look at things they don't say directly.
That's right. So working observations is shadowing. You're basically just watching them, things indeed, Bettina. You're just watching them doing things, and these are the actual interviews you run with them, right? Also sessions with stakeholders, PMs, and developers, and then ultimately trying to understand the logic and complexity that we're dealing with here, right? In that particular project, what was really important also is to understand the workflow sequence and basically to reverse engineer it. Because if you just ask people how you're working, very often they imagine a perfect workflow that does not exist, so you cannot trust it. If it's self-reported, it's not quite the same. So we need to be quite careful with that. Okay, so this is what it looked like. So you go in and you observe people working. That's pretty much it. And so that particular user here, an engineer at GexCon with 13 years of experience, right? 45 minutes, right? And so he was producing, or he was working on 2 different tasks within this 45 minutes. And so this is how he's using the product. He has his own laptop. He has another laptop that's attached to it. So it's 2 screens, sometimes it's 3, right? And they will be using them at the same time because there's a different views of the same space. And often they need to map out whatever it is that they have at the bottom here into the geometry that they're setting up here. But specifically in here, so he has to run a leak wizard and also define pressure relief panels. I don't even know what that means. But here we go. And then in the end, basically asking him, so how easy or how difficult was it on a scale from 0 to 10, from 1 to 9, or from 1 to 10, I believe, over here. And so here we go. So apparently it was quite difficult. Apparently it was not so difficult. Maybe you can observe also what they're doing and take notes. I don't really do these kind of things, metrics and misclicks and clicks. That doesn't really mean anything to me because if it's 11 clicks to 23, as long as it's predictable and people know what they're doing, that's kind of okay, right? But I don't really, I'm not obsessed with clicks. One thing that's worth noting here in this sort of environment, again, you have a nonlinear workflow. You don't have a journey that people always take. Some journeys are similar, and so this is, could be sort of again a hub that we might want to improve, right? But still, there is not a fixed path that everybody is taking, and it's sort of a similar sequence of actions, but people go through that at different speeds. They go back and forth a lot, right? So globally, it's kind of there is a sequence of actions because they get from geometry of the page to modeling to running those experiments to getting the outcomes. But in between, there is an enormous amount of chaos and moving back and forth. So if you wanted to just design a user journey map, this would be a very simple journey map it would not be very helpful, right? And so then we also have very different expectations that they come along with it, depending on the project that they're working on. So altogether, there were 102 different tasks that were documented. And in describing them or capturing them, the designers asked to describe the goals for each task, how often the task occurred, the level of difficulty they experienced, and actions they took to complete it. This was the outcome. But look at all these 102 tasks. These are represented as behaviors, right? 1, 2, 3, 4, 5, 6, and then 96 more, right? And for each of them, we define frequency, how often somebody would be doing this, desired outcome, kind of the user need, the user goal, I guess at this point, the complexity as they perceive it, right? The patterns that we have observed, right? And then the needs, which is basically the needs that we think they have, because there is goals and there are needs. Now, this is something that the person is saying, right? But here we go. At this point, the person is saying, I need to import a scenario so I can run a simulation faster. Makes sense? But maybe there is a way for a user interface to set up several scenarios quicker, right? Maybe that's something that they actually need, right? So why does it matter? Because if you're looking, let's say, on the prioritization, what to work on, if you want to make a difference, right? Again, every product is like a city. You need to find things that people use a lot, which means I'm going to look for a perfect storm. Very high frequency, very high complexity, right? And a lot of frustration, right? So if you can find that, that's great. Very high frequency, high complexity, a lot of frustration. That's where you're going to make a huge difference. However, this is not everything because sometimes there are tasks that are really important to get right, but they're not frequent. Like, for example, maybe you file your tax return once a year, but it must work. Maybe you're preparing a report once every project, and that project maybe lasts for 6 or 8 months. So it has to work. It's really critical. It's really important. So it's not just about frequency, right? But Or every now and again, if you have something which slows people down, right, in maybe every session or every other session, that's a great candidate. Now, this is also, right, and again, this is maybe like me 45 minutes later coming in. This is also a great candidate for AI improvement or AI enhancement. If something is repeatedly used over and over and over again, it has a relatively high complexity and it's very frustrating. Well, if you can automate at least parts of that with AI, right, given that AI has like 90% accuracy still, then you can do quite a difference, like really quite a difference. But ideally, it would be high frequency, right, high complexity, but also along with it, low risk. So if the risk is high of getting things really badly done or incorrect or anything like that, then it actually maybe doesn't speak necessarily in favor of AI. But if you have low risk, high complexity, high frequency, that's great. So if anybody ever asks me, so how do we choose what to work on? Now that's how I choose what to work on. There's nothing magical here. We just see what happens. Does it make any sense, everyone? Now, that assumes, of course, that you have access to users. So that's another story. Sometimes you don't. So that's it's a bit of a different situation, right? But you can maybe also still look in logs and stuff like that. Okay, so what's the next step? Well, from that point on, we need to understand what to do with that. So we can maybe identify certain behaviors, right? And then we need to convert those behaviors or those tasks into something like a requirements doc, because this doc is everything. Again, especially as we're going to dive into AI in like literally 5 minutes, right? We need to have a very clear document that documents everything that we need to do here, that also documents how we make decisions. I mean, not us as designers necessarily, but people who are going to use it, right? So their way of thinking, their mental models, their habits, and everything else, it must be documented. Otherwise, there is no chance AI is going to produce anything meaningful at all, right? Depend on how we actually want to use it. So it's really important there. And so what we do then is we actually write down things, specifically the definition of purpose, any constraints that we need to be aware of, any dependencies, and expected behavior. Now, with this, there is one thing that I need to mention. Of course, we moved away with AI from the point of saying, well, we're just going to give AI a couple of guidelines that it's going to respect. No, we don't do this anymore because AI oftentimes does not respect these guidelines and whatever rules you give it, right? So instead, we do it differently. Instead, we do something that is then called harness engineering, where we create a deterministic space, just a regular software with loops, right, where agents are checking the output of AI permanently against those requirements to make sure that AI is actually delivering on its promise, right? So we don't say, hey, AI, you can do everything, but please respect these rules, right? Instead, we say, hey, AI, you're going to be cut off from the world in a very deterministic box. You can still do a lot in that box. You can maybe go to certain services, go to certain documentation files and whatever, right? But you are just here. You can do whatever you want in that limited amount of space that you have and be creative about it whatever if you must. We don't just say follow these rules. Instead, we create the space where these rules are enforced, whether AI wants it or not, right? Okay, so I hope that makes sense. But all of this is just to say that we need to be very much aware about purpose, constraints, dependencies, and expected behavior. Now it looks like this. This is a component from that product, and it's a component brief, and it also has a list of attributes it must include, right? Component brief. The component should allow for highly flexible plot creation, setup, and customization to support anything from a single simple 2D chart to complex dynamic 3D visualizations. The user will analyze the data from single parameters to aggregated data like comparing two simulation sets or two geometry variations. The component should also allow the user to create data visuals for communication purposes like client presentations or research projects. Here we go, and it must include all of this, and this is maybe like a prototype or mock-up of what it could look like. Plus, very important, there might be quite a few things that you might need to change. So you need to be quite careful about what you're actually prioritizing in terms of UI, what is being displayed and what isn't. So you kind of need to think about visibility rules. What is meant here is that things that are used a lot, again, this is why we're asking for frequently used things, right? They must be visible at all times. They must be visible at all. I can repeat it many times. Things that people use a lot, independent of how many there are, right? If they use them every day, a lot, they must be visible at all times. And so you then start playing. If you have defined things that have high frequency, they must be visible at all times. Now that means you start playing and you keep playing and keep playing, maybe keep playing a little bit more, and eventually you will see it just shows up like more and more stuff. Well, because all of this indeed must be visible. Now, the result then is, of course, something like this, where all those things that you see here, right, have reasons, right? You might say, well, there is a lot of navigation here, there is a lot of buttons here. Well, if they are frequently used, and we know from the testing that these are the most common thing that people are doing, like in a city, we need to make them front and center. However, of course, what you can see here is that people are going to be applying very different modes. Sometimes it's geometry, sometimes it's scenario, sometimes it's grid, the solver, and so on and so on. But those things must be here. So they were not here before, they must be here now. And often you have the shell architecture, we have the navigation, the global navigation on the top, you have the tabs, and then you have the main actions from that part, and then you have the sidebar coming in, and then whenever you have kind of drill down further and further and further, kind of go from left to right, and then you have your UI. Plus, maybe within it, you have some tabs as well, right? So there is that. But then what we shouldn't be forgetting, of course, that often we need to really make sure that the essential complexity is maintained. So if it comes to gas clouds, for example, well, you probably need to design something like a design system for that to make sure that you understand the physics and you illustrate it carefully and correctly, like this, right? So there might be two different types of explosions, right? Or mixtures, and different outputs and different mixtures will produce different results. So you need to be very much aware of that. So they are going to be also showing up here as, as icons maybe, right? And on top of that, it might be a very good idea to create something like a mnemonic color convention for orientation axis. That's something that you do in an innovation workshop separately. So it's not just rebuilding what you have, but really rethinking how you can actually get people where they want to be, can be more successful. So maybe create something like this. And as a result, you create maybe a little orientation axis over here in the design system for that. So if somebody who is looking at it, they will understand what is what. And again, just don't forget that they'll be learning this relatively quickly if they're using this product for 5 to 6 hours a day. So, and here we go. And the outcomes, which are kind of defined early, is metrics, well, design metrics. I've been speaking about design KPIs and UX metrics for a long time. There is almost no project that would start without it because, well, you need to understand what is in front of you. For example, one of the things that they established in early on as metrics is how much time does it take for somebody to set up a first successful simulation. It used to be 4 days on average. Now, after like 2 months of training and using the product, 6 hours. How many errors occur? Few errors, that's good. How much time did it take to fix a mistake on average? 20 minutes, used to be 4 to 6 hours because there was a lot of feedback, lack of feedback. And then how many active users are per team? Used to be just 1, now 3 to 4. And then also training and onboarding could be replaced with short webinars and video. Now that's, in my book, represents success, right? But at this point, you might be thinking, okay, so what does it mean and how does it all relates to AI? I mean, at this point, we spend like 54 minutes really talking about complexity and how to deal with complexity. And it all starts by understanding the problem space, by doing a bit of research to understand, again, at least enough to start feeling comfortable and confident about it. Then break it into tasks, run two sort of workflows analysis, the task analysis and workflow analysis. And then once you have that, you need to understand the frequency, the severity, the complexity as reported by users, and whatever observations you can add on top of that. This gives you already clear prioritization about where you can make a difference. They turn them into requirements document, which really meticulously documents everything that you need, how people think, right, as well. And then from that point on, you create visibility rules to make sure that you actually always show things that people need to see. But how does AI fit into this? Great question. AI fits into this with those requirement documents that I have identified, right, or mentioned. And this brings us to the notion of context engineering. Because with AI, right, a lot of conversation that we've seen happening, right, is not about how to add a chatbot. I think at this point, while a lot of products are very much like this, We moved so far away from it. And a lot of AI products that are being designed and launched today, they are on a very different, like from a very different universe. They're really, really remarkable. There are not many of them, but they really are. And these are not chatbots. And obviously, I'm going to show you some of them as well. So how does AI fit into this? Well, first of all, we need to understand where, not how, but where it fits with AI. This is the wonderful little overview by Emily Anderson, I think. I need to double check on the layers of AI experience. And I'm always very confused because people always say, well, AI is easy. It's not easy. There is a lot of stuff that we need to be considering and we need to keep in mind. Now, on the one hand, we have the different layers of experience we have to be considering. Like we have the UI, but the UI is not necessarily the most difficult part. The most difficult part is actually context that you're accumulating about not only the prompt that somebody is submitting, but any other contextual information that might be relevant for us and for AI to give the most accurate response. That means any background information you have about them, any past history that you have about them, any knowledge you have about them, any behavioral patterns that they've been exposing, any system that they have integrated, any historical interactions, anything else that they have that could all guide AI toward a better solution. And to get here, we need to make sure that we actually have AI operating in a way that is not, well, at least minimizing hallucinations. This is a separate story in its own. If you're looking into harness engineering, if you just type in harness engineering, there's a big field around this about how to tame AI as well, maybe more on a technical level. But this is where we're talking about the usual stuff, like the agents and the skills that maybe you have been using as well, the tools, the connectors, what AI has access to, right? By the way, that context could be explicit by provided by users like files or question or inferred based on the past behavior. Sorry about this, I'm not sure where it's coming from here. Then we have the model, then we have the governance, and then we have just the mess that AI represents because it's just probabilistic system. Cannot eliminate it, but we can design the conditions and create environment where it actually performs better. For example, by cleaning up the data, right? So what does it mean? Well, if we have this as layers of experience and we need to design AI, our world, this requirements document, for example, would fit right here. That's the context we are producing, ideally along with harness that maybe we will not get in a moment, because this literally just limits what exactly AI has access to. Now, what the hell is this? And what is context and what is context engineering? Well, it kind of brings up a little bit of a story for us because, again, it all started back in 2022 with this, right? We looked into prompt engineering. And you might remember seeing an unlimited number of posts about these are all the prompts that you need to memorize and tattoo on your chest and keep them in mind every single time you interact with AI because this is everything. And I always ask myself, why should I remember this? Shouldn't AI be smart enough or intelligent enough to take care of that? And then I was quite happy just a year later in 2023, having discovered this wonderful paper on AI prompt engineering being dead. That's nice. Coming from iSpectrum, which I kind of trust, I guess, at this point, right? So AI prompt engineering is dead. I thought that I think is good news, but why is it dead? We're still prompting, right? Well, if you ask a language model to create its own optimal prompt for any kind of context that you're providing, in almost every single case, automatically generated prompt by AI will perform and produce much better results than the best prompt found through trial and error by humans. In other ways, people are really, really, really bad in articulating their intent. Really bad in articulating their intent. What does it mean? Well, it means that it changes everything. Everything. Because if you look, let's say, at Figma Make, this is a wonderful example from a letter. A letter has received a draft, sorry, a brief. A brief which was translating or transforming insurance form, with 22 pages long insurance form, into a beautiful digital journey. So while producing this wonderful prototype over here, which looks pretty nice to me, I have to say, she never typed a single word on a keyboard. Not even once. Not even one. In fact, she went through 22 versions, as you can see over here, without ever typing any single prompt. How would that work, you would say? Well, obviously it will take quite a while to go there, right? But this is a letter prompting the way. Well, she never wrote it. Would you write something like this here? That's fun to write, right? Not quite. Or would you maybe write something like this? Let me just double check here. Let's go back up. This is a nice prompt to write. Like I can see you almost really being patient, taking a cup of coffee and thinking, today I'm going to write a perfect prompt and it's going to look like this. No, she did it differently. Namely, she takes a brief that she was working on, and now she says, let me record a Loom recording of me going through that brief and speaking to AI about what I think about it, what is important to me, how I try to solve it, how I try to change it, how I try to modify it. So she does all of that. And then as a result, she asked AI then, hey, can you just generate a prompt in Figma Make that will create a first mockup for that, a version of that? And this is the very first prompt. As you can see here, some of those are quite detailed, right? And so we've got that. Along with that, she of course submits also the brief on its own. So that's kind of helpful, right? And then after 1.5 hours and 22 versions or iterations, she gets to this. And again, if you look at me, pretty good, I would say. I mean, pretty impressive, in fact, right? I mean, once you start going through it, obviously you have a lot of things that are kind of maybe confusing, like that's not nice and things like that here. But it kind of works and it actually covers 22 pages, which would probably take, I don't know how much time to produce, right? So I'm curious how much tokens it costs. I don't know, I never asked. So here we go, right? Tokens, separate story. So that's again the point. You will never write a prompt. I mean, we are living in 2026, everyone. Why would you write prompts anymore? That's just not cool. We just don't do this anymore, right? We ask AI to write it for us, right? Okay, but then we have what instead? Well, instead of prompt engineering, now we have context engineering. And context is everything that the AI considers and is aware of when answering users' queries. Could be sources, documents, files, but also things like levels of expertise, code, history, or anything like that. There are quite a few things that are worth knowing here. And if you look at data and research on context, you will find that people are speaking about it from very different perspectives. For example, there is a famous paper which is it's called "Context Rot: How Increasing Input Tokens Impacts LLM Performance," and it actually says, well, context is extremely fragile. Context, again, everything that AI is aware of, right, when answering your query. Well, when a question is ambiguous or doesn't perfectly match the phrasing within the context, the rate of performance decay accelerates significantly. That's something that is called context rot or context poisoning, something that's maybe also some of your colleagues might be speaking about in terms of like as engineers, right? But also with this, if you give AI too little context, it produces vague answers or hallucinations. Too much context, it makes it difficult for AI to focus on relevant parts, so it gets confused. It's always this really strange balance that's very hard to strike between giving it too much context and too little context, right? And also, I think it's worth noting, of course, that context is not just static, it's fluid. As I keep going in the conversation, the context evolves. The parts that were mentioned get dropped out because of the limited context window, right? And so some parts are relevant, some parts are partially relevant, some parts are irrelevant, and it's very difficult for AI to actually to know, right, which one that is. It just assumes that certain things are more important than others. So how does it relate to what you actually have in front of you? Well, this depends on how deep you want to go, because most projects, right, when they're dealing with complexity, they go in and they just dump a lot of data in a context layer and call it a day. And then they get surprised why they don't get good results. Well, because it's not enough to just kind of dump a bunch of data that you have, like documentation or anything like that. You also need to guide AI. We're kind of moving to the world where we're basically not speaking about, just AI or AI first. To me, AI first is a very strange term, right? We're speaking about guided AI experience, meaning we are guiding AI to do the right thing for us. Similar to how we would onboard somebody who is maybe very knowledgeable but doesn't have a lot of experience. You need to guide them how you think, how you make decisions, what is important to you, and so on. So instead of just giving them a bunch of documents and say, good luck, I hope you're going to finish by tomorrow, We say, hold on, this is what is important in this document. This is when you should use it. This is how you should use it. This is what to do with it, what not to do with it, and so on. That's already better. So providing a bit of guidance, I guess, around that data that you actually throwing at it. Along with it, maybe you can define and provide some rules, business rules, logic, reasoning, how it should be thinking through the problems and stuff like that, how to provide responses, right? Just to minimize hallucinations. You can go beyond that. You can say, well, I actually have a specific output constraints that I want you to respect. They are predefined, so please make sure that they're all mapped against the business logic, design, and UI. And then eventually, I want you to evaluate how well you are performing. And here are the success criteria that I have defined for the task that you have, along with ground truth data and test cases that define what good looks like for that specific use case. So that's context engineering. So it's not just throwing a bunch of data, but also explaining the data, explaining the logic and reasoning, how to deal with data, explaining what exactly you expect as output of that, AI reasoning, if you like, and then how to evaluate itself to see if it's actually performing well. And that's context engineering. Does it make sense, everyone? Now, this is not easy, right? It's not like you can do it in a day or so. If you want better results, that's the level of detail you would go in. And remember, we have this task that we have identified. We have requirements document that we have defined. For each of these tasks, which could be perceived as a journey on its own, we need to have a very clear detail about data mapping, logic, reasoning, output configuration, and then evaluation. If you want to make a difference and really bring in AI into this, you need to make it as thorough, clean as well, so no duplications and no conflicting data or anything like that, as you can. That's the only chance that you have. Otherwise, it will be just relatively random. The one thing that I want to mention here is that oftentimes you have a situation where you have a loop in place. Like this is also now called loop engineering, where the idea is, well, as you're evaluating, you basically have these running loops where you say, hey, I wanted to try to get to a better place as much as you can. So iterate, 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 iterate until all success criteria are met, until all test cases are completed successfully, right? And until you actually have respected certain rules and checks. And this is, again, running an AI loop within deterministic software that always checks the output and then keeps going. Now, that produces an enormous amount of tokens, right? That's expensive to run. But if you want really, really, really high quality, then that's the level of ambition that you would go for. And that's what companies sometimes would be doing. But that's remarkably expensive, right? That doesn't come for free, right? Okay, so how would that then work? Well, for a short period of time, I was working with NetSuite, but the team at NetSuite, at Oracle, and they produced a couple of things which I think are really, really nice. Like, for example, this. This is a very simple, relatively simple ERP system. Well, not simple. It's an ERP system. Some of you maybe worked on one. And what you have here is basically a reports list and a data table with a lot of dependencies and filters and all this stuff. So the way of how interaction looks like here is this. So you have an Oracle, which is called Omnibox at the bottom. And you can ask it a question like, what was my gross profit in year 25 compared to previous year broken down by the quarter? Right, so it gives you a response. But what it also does, because it has been trained like this here, again, going through different levels of context engineering, it's going to flag assumptions. So if it doesn't know anything, it has been trained to flag things that it probably assumes at this point, right? And then it generates stuff as well over here. And you can collapse it if you like. And then as you can see here, these data points, they are not just, static text. They are pointing to where they're coming from, what you compared it against, and what the data source is. And if you click on it, it points to a specific cell in a data table where it's actually coming from, so you can interact with it and can check it, right? And once you do, right, you can also do the opposite way, where you can say, well, I want to maybe look up specific data point that we have here, and maybe summarize it for me, and maybe also explore things that I should be looking for, and maybe even forecast things for me as well, right? So I like how deeply integrated all of this is. And on top of that, what you also have is little explainability. We call it AI explainability, where instead of just giving a wall of text explaining how you actually came up with certain solutions, it basically highlights a summary about what it has been doing, how it understood the question, where the data come from, which dimensions were used, filters, and what kind of breakdown and so on, and which logical steps and assumptions were made. It's very clean, it's very short, right? It's get to the point, and it's also deeply integrated in where the work is actually happening. It's not just an assistant, right? You can just interact on it by clicking on a table cell and interacting with that tool, right? And on top of that, what I think is really worth going through is that they also have this little canvas that you can also plug in. You can have a conversation ongoing, but then you can also have a canvas where you basically say, that chart, that's nice. I want to save it. I want to keep it. I want to use it in my canvas. So you can bring it in there, right? So as you keep going with the conversation, and maybe some parts of it become irrelevant, but you always can cherry pick the parts of a conversation that are important to you and bring them in a canvas to use later, create a report for later, right? Very nice. I think in many ways it actually does the job fairly well, right? And it also something that really started showing up quite a bit. So maybe just 5 minutes, everyone, and then I'm happy to answer any questions that you have. Because this brought up a new way for things. Again, once you understand and write down the tasks, what people are doing, how they're doing it, right, and you fit it into AI, then you have a much better chance of being successful. But it ultimately brings us to this really new concept, I guess, that started showing up now, which is this notion of context of thinking infrastructure, where you really supply AI with how you think, with how you make decisions, what is important to you, what matters to you, and all of that stuff. And this is why we have this big explosion of skills, right? Skills to me is just a file which is allowing me to borrow somebody else's way of thinking, somebody else's expertise, and bring it into my place so I can use it, right? So we have this huge agent skills, shortcut as well. This is just skills with 270,000 skills that you can just borrow from, right? Or here 22,000 skills. Or I mean, this is a really, really huge space. We're talking about literally hundreds of thousands, I guess, skills that you can find here. And each of them is not really groundbreaking, really. I mean, that's this, really. That's just a markdown file. And in that markdown file, you kind of explain how you work, how you think, what artifacts you need, what the output is, what the input is, all these different levels, they are just displayed here, like in plain text. That's why UX writers have never been busier. Because somebody has to write it down, right? Who else is going to do that? Most organizations don't even know how they think or how they work, so somebody has to write it down. And this is why we call all of it the notion of guided AI, where we pre-write thinking, pre-write how we make decisions, the principles, the context, and everything else, and feed it into AI. And ultimately, that also brings us to this world of AI-ready design systems, right? Where we're creating a spec file which describes all decisions and everything else that we need to supply AI with so it can make better decisions, right? So for example, we have spec files, which are basically reference docs for UI components, tokens. You have basically something like an audio script and sync routine flags. Let me maybe show this. This is coming from Atlassian, and they have a really nice case study that they published on how they actually made their design system AI ready. It's called Expose Your Design System to LLMs. And they basically explain exactly this. Traditionally, you would do this. You would say, well, we have a system, and then AI reads it once, and then it produces a result by guessing on something that's missing, and then it starts drifting, and then it could produce inconsistent output. So we moved away from this because it doesn't work. So what do we do instead? We have a loop. In that loop, we have something else. So we have a design system. AI reads the specs, which we're writing for every component. It could be like requirement document that you have as well. Then it uses tokens from the design system documentation because it's scoped to that. Then, as a part of generation, it has a mandated audit that looks up for any drifting by comparing it against the design system guidelines. And then it produces an output. If that output is not consistent, it's going to start going back and rereading the specs and trying to reuse the tokens and clean up. So there is a loop which basically forces AI to get better over here, and it doesn't pass through until it's actually meeting those requirements. And once it does, it actually produces some output. And then with this insight that it has learned, because probably there might be some gaps that it has used or tried to fill in and tried to guess, and it just couldn't get anywhere. Sometimes it's also requiring the human's input as well. And once it learns something, it automatically updates the specs, right, that it has over here in the document design system with regular source sync. And then you have a loop here. So you have continuous spec that keeps going, keeps growing. Then you run an audit, and then you enforce it by really having a loop here with mandated audit looking out specifically for things that are inconsistent. In this case, they were using it to generate prototypes, right? And just to make a point here, right, this is really quite significant because, of course, if you look at the design system by Atlassian, now there's a big design system that they have, and it looks nice, right? But you would never serve it to AI as is. Why? Well, for two reasons. Well, first of all, this is a lot of mess. Why would you serve this to AI? You would serve it HTML. That just doesn't make any sense. That's just really weird. Why would you do that? Instead, you would serve it LLM's txt file, which is a design system. Well, LLM's txt. Who is it? Hold on. This one. Here we go. LLM's txt file, which is basically an Atlassian design system, but it is now AI ready. This is full Markdown. And it's not just a reference, right? Not just a copy pasting documentation from, visual format into text format. No, this also includes guidance. For example, if you look at every individual components, like let's say over here, right? It actually is context engineered in a way, right? Where it says, well, this is what you need to keep in mind here, right? This is an example about what we have here. This is some props we're using, but also there are guidelines that you need to keep in mind here. Also, this is for accessibility. Sometimes what you also find is priorities, right? Meaning you need to try to do this. If you can't do this, try this. That's kind of explaining or defining the way of thinking as well. And so this is quite meticulous, right? There is a lot of stuff. And again, all of it is coming with usage guidelines, content guidelines, accessibility guidelines, and also then examples, what to do and what not to do as well, right? And again, when they're producing something, right, this gets updated automatically by AI writing the spec or updating the spec with whatever it has learned in the previous iteration. Why would a human ever write this? That just may be a little bit unnecessary, unless you, of course, want to have ownership over this, right? So that's sort of the story of where we actually ended up. So with all of this, let's wrap up. Oops, I actually need to go back here. As you can see here, I mean, I started off like maybe speaking quite a bit about the complexity, right? But I think that this is such an important part to keep in mind because you cannot generate any meaningful AI work or any meaningful prototypes or anything decent with AI at all, be it on the level of design, code, or, I mean, although his code is better, but anything else really, unless you actually understand the problem fairly well. And for me, it all starts with these two notions of task analysis and workflow analysis. Once you have that, you have everything, right? So with this, I want to maybe just briefly show you the little story of my life, which I think is maybe a little bit sad at times, but it's also very much true. It kind of explains my life, and maybe this is your life as well. So it's always very difficult to make things right. And it's quite confusing, especially with AI. It's really, really hard and complicated, but we have to do our best. So welcome to my world. Maybe that's your world too. Well, sorry about that, everyone. Sometimes things just don't go as expected, right? So huge thanks to Parallel Studio for the wonderful video back in 2016, I believe. With this come cats and more cats and meow, and thank you so much for being around here. Oh, it says 2025. I'm pretty sure that harness engineering and other things didn't exist in 2025. It's moving much faster than that. But here we go. So thank you so much for joining, everyone. I hope this was useful. I'm going to stay for like maybe 20, 25 minutes for any questions that you have. Uh, just before you go, yes, recording will be may edit over here, but you also will get an email for that. So watch out for that. Also, this is a Google Doc that we've been using. Maybe some of you missed it. Also, just in case we have some fun stuff. Well, we have some fun online workshop coming up, but I also have a legacy workshop and enterprise UX workshop. If you really want to torture yourself more, good luck with that. And also for like AI course too. And of course, AI cohort, 4 months, 4 weeks long, 6 weeks long. I think Gilad is coming from it now. Tortured by it. Excellent. So maybe this will be helpful. Feel free to share it with your friends and colleagues. This is not a problem. You're very welcome to share anywhere and with anyone as well. Now, it's time for you to bring up any questions that you have. Excellent. I'm going to just jump in right away. Thank you so much, Luis, for coming in. Thank you, Uma, as well. Jala is wondering, if asked to create a dashboard for a system, does it make sense to show the same data as the chart in a table grid format? Because a chart does not give us comparative view at once. It's easy to compare things quantitatively in tables. Looking for more ideas on the same. Dashboard for a system, does it make sense to show the same data as the chart? I think we need to have both. That depends, of course, on the nature of the dashboard that you have. But often when it comes to comparing, of course, comparison is much faster, much more efficient with the table than it is with charts. So if the purpose or the job is, or the task is to compare, the table is better. If it's more to visualize or explain or draw attention to something, then the dashboard. But sometimes, why not both? Jennifer is wondering, in the income statement AI example, how can you be confident that AI did not hallucinate the explanation of its own logic steps and assumptions? Now, this depends on how you engineer it. So this is also very much the notion of harness engineering, which has been making rounds recently because we need to tame AI to do the right thing. And what that means is, and it's not coming like from me or anything, it's coming actually from OpenAI and Anthropic, but I spent a lot of time trying to understand how to reduce the negative impact of hallucinations. To achieve that, instead of giving AI restrictions about what it should do, you put it in a deterministic box and you give it access to certain tools, and then you ask it to do things, and then you check and evaluate the output of what they have produced with deterministic testing tools, like the unit testing or any other tool that you would be using to check if the output is actually good enough. And then if it isn't, you ask it to do it again, but also you generate a prompt to guide it to a better solution. And it keeps going. And it can go through these loops quite some time. We moved to a way, like if you actually look at it, this is really fascinating. We moved to the situation, like this is quite significant here, where back in 2020 or 2022-ish, right, ChatGPT, like GPT 3.5 back then, right, could maybe run a task, that would human would need 36 seconds for on average, right? Looking up movies and stuff like that. Now we are living in a different world. Now, looking at 2026, right, we can have AI running for tasks and producing output for tasks that would usually need 16 hours of humans' effort to be done well. So that means that you can easily have an AI agent running for a couple of hours. And if it does so, and it produces things, and then it checks itself, and then it produces again, having learned what it has learned from that, you can get pretty good results. It's just expensive, right? So there is that. Let me just double check here. One more thing. More questions coming in here. Okay, see a few more questions coming in. Just a moment. Oh, hello. Wonderful, Jose. Wonderful. Thanks so much for joining in. Excellent. Personal tool stack for AI-assisted prototyping. Do you use Figma prototyping, Playground artifacts, etc.? I used to use Lovable, but now at this point, I become a huge fan of Claude Cowork. So for me, everything is Claude Cowork, like everything, literally. So I don't use anything else. I sorry, I didn't. I used to use Lovable a lot, but I don't use Lovable at all anymore. Um, Nothing else. Figma Make, no. Just Claude, no, for me. But there might be restrictions coming up, I think, next in August in terms of tokens usage. So we will see how it's going to evolve. About guided AI, says Yahya, how about starting from the end, then work with LLM how to get there? So the point with this is we learned, for example, and this is kind of coming from this wonderful session. Here we go. A secret sauce for prototyping with AI. I think I also have a link to it in the Google Doc as well. We learned that it's a bad idea to give AI a visual and say translate it into code. Doesn't work. In the same way, it's a bad idea to say, hey, here's a visual what I have, produce something, dear AI. Like this, or check if it's accurate or not. Well, because very often a design system, however comprehensive it is, it still has gaps. And still has snowflakes that actually confuse AI more than help. So in fact, the direction that works much better is to start with code, right? And this is again why we have this kind of markdown file, which is basically code here, right? And then say, now generate a design based on that, or generate a prototype based on that. That seems to be working way better than if you give it something like a visual and say, now create a flow out of that. You always start with the code and then you ask it to generate something and then you move from there. That seems to be producing just better results in general. Right, let me just come back here. Okay, there's so many wonderful questions in here. Thank you so much for the notes. Michael is wondering, I'm always asking models, what do you need to do differently to prove this change works and fits our goals? Interesting. What do you need to do differently to prove? I mean, I always ask it to challenge me. So I think that Claude really hates me. Sometimes I feel like it. It really punishes me. Whatever I say is wrong. And it's never pleased by whatever it is that I'm doing. It's a bit, maybe it's also just the way of how I speak to it. That's a bit not fair. Anyway, thank you so much, Valerio. I'll take a look. That's also interesting to see. Really, is it like LLMs full here? Oh, I didn't know that. Oh, that's nice. Thank you so much. Wow, that's a lot. Okay. Just jumping in further. Okay, more questions. Spencer is wondering, for exposing the design system to LLM, it helps for designing using the established system, but what about exploring beyond to solving new problems or evolving the brand, etc.? What the proposed workflow? Very good point. I think there is this very famous model, AI design innovation by McKinsey. They call it like the Gardner, maybe. Uh, Diamond something. Oh my God. Not, oh, here was this one that they put together. That doesn't work for me. The idea behind it is a Stingray model. Okay, I guess. Where you basically say, well, we need to figure out what is going to AI going to do, what is human going to do. Well, sorry about the quality of this, right? So you basically say, I have a problem, AI, go. You iterate, find solutions, and go through it. And produces maybe 1, 2, 3, 4, 5, 10, 15 different directions. Then you look at these directions, and then you basically say, okay, I like this. Let me start taking this and build on top of that. I can't do this. To me, this feels like I'm getting guided to AI, and I feel like I'm really not using it to the best of my abilities. What I actually want to do is I want to think. I literally just sit down and I think about this problem and I think about what should be the best approach to this, to fix it, to address it, to resolve it in some way. How should I think about this? Like maybe I should be considering something else. And then I play with AI to say, well, this is what I've been thinking. What are the holes in there or weaknesses or anything like that? Maybe generate something that would actually work better than what I have suggested. So I start from my idea, right? And then I ask it to build it out basically, right? And test it and stuff like that. Instead of just saying, hey, AI, go it, here is a problem, just knock yourself out and try to come up with something, right? But I'm And then you kind of take it back and you take control over whatever it is that has been produced that you actually like, right? And so on. I would say that most of the time, I find myself in a situation where I like to really spend enough time to understand the problem space before I get into AI. I mean, sometimes I would use AI, of course, just to do research and stuff, right? So that goes without saying. But personally, I don't use synthetic testing, right? Or anything like synthetic research. I know that some people are like it. I just never really tried it properly, maybe as well. The point of this is that you can actually run some sort of an experiment and not experiment, but simulation, not simulation. I don't know what it is. That you can give it, give a problem and then say, let's pretend that there are 1,000 users who would be my users, and you can run a test with them and see what they do, what they don't do. Personally, I would always choose spending time with one customer in real life than just training it over to 1,000 agents that pretend to be humans. But maybe I'm also biased here. That's kind of my take on this. Personally, I would maybe for something where we don't have access to users, I would try it, but not when I have access to users. Let me put it this way. Not to say that I really hate synthetic users or something. I haven't properly tested it yet anyway. Right? Let me just double check. What is the personal tool stack for AI? Okay, that's already was here. Okay, that was also here. Good, good, good. Best practices for making sure the AI agent actually ingests the design system spec correctly. Well, that's again, at this point, the best thing you can do is to try to work and refine this sort of AI ready LLM's TXT file to make sure that it's actually most comprehensive it could be. Any recommendations for skills? Yes. Oh, yes. There is product layers, which I love. This product layers is describes the way of thinking that is very much close to what I've been thinking. You might remember this little overview, like from reality to problem space to solution space. This is coming from Jamie Mill. And Jamie Mill created this wonderful free skills pack. And it's so nice because basically it's you give it a problem and then you run it through these 7 different steps, right? Observe behavior, domain, user needs, product, service, strategy, conceptual model, interaction, structure, and flow, and surface. Along with each of them, it actually has described a way of thinking, how we make decisions, what is important to consider, and stuff like that. So of course it can go in on the web and do research and all of that, but it's a nice way to get started. So I highly recommend you that one. But if you're looking for more, I put together more because I was just curious about what people are doing. AI skills. Let me just give you. This is the one. I think this one's also on accessibility and many, 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 many other things. So this is going hopefully will be helpful for you. This is just one. This is actually where I'm describing what I actually have been highlighting here. But this previous one that I was highlighting here has a lot of stuff for research, for writing, for strategy, and so on. So maybe you'll find it helpful. All right, here we go. Let me just double check. Do, 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 do. Jose is wondering, do we need Figma at all? I think so. I mean, somebody needs to design. I think that we still need designers to actually design those experiences because many of those AI experiences or AI powered experiences are pretty mediocre. So I'm pretty sure that we need some way to design, I think. Um, Michael, thank you so much. That's very kind of you to say. Also, Christian, thank you so much. Yurask is wondering, is it okay to start directly in Claude for ideation phase and in visualization layer, which could be used as second step instead of iterate on results? Sure. I mean, whatever works for you. I don't think that there are any rules at this point. Everybody's doing whatever works for them, right? It just for me, I think I'm always missing just the time when we sit down and we think. Even when it comes to teams that are very much design driven, there is often this need to do group thinking. Let's get together and start brainstorming. Just give everyone a couple of hours to just think through this problem on their own and then bring those ideas to a shared space, like a brainstorming or something, but don't let them come empty handed. So let people give a bit of time to think. We tend to forget about that, I guess, in some way. So Maybe, sure, just go ahead and just let people explore first and then bring them together to see what people have discovered, what they've been thinking. Makes sense to me. Spence is wondering, AI always wants to tell me how good my idea is, though. It loses track of the original challenge. It does, most certainly. Right? Bettina is wondering, hello, Bettina, wonderful to see you back. When it comes to designs, or employers often have concerns about security and trade secrets relating to future developments. Do you have any experience with cloud design in this regard? I think they were speaking about something like that. Maybe that's also something that David is pointing to. Because I think you can opt out, but you need to have a special license for it, or kind of pay enough for it as well, I think. But I also just want to mention maybe that there we see quite a big shift happening now. Um, there is, for example, LLM Arena. LLM Arena? Yes, well, no, Arena AI, which is basically just looking at the current state of the models and gives you a leaderboard of them. I mean, there are 32 established models for agents here, but for everything else, if you look, let's say at, I don't know, search, right? We are looking, oh, keep going. We're looking at, oh, actually it used to be more. I'm not sure why it's like that here, but hold on, let me come back. Okay, so for text, for example, generating text, 369 models. Now, if you look at them, many of them are familiar to you, so Gemini and Claude and so on. But there is quite a strong trend now, although it's shifting now, to go to Chinese models, which are open weight. And what we mean by that is you can put them on your premises, lock them down without access to internet, and then you have them ready. Now, why is it a big deal? Well, it's a big deal because, for example, Airbnb was the first team, I think, that actually moved to Qwen back in, when in May 2026 here now. So they went all in on Qwen because it's cheaper, it's efficient, and frankly, pretty similar results. Not the same, a little bit worse. Similar results to what you get in Anthropic, what you get in OpenAI for quarter of a cost, right? In fact, there is this little token visual, token blast, no, token cost, something cost token. Damn it, I had it. Oh, hold on, I think I have it here. Token. Oh, here we go. Tokens Blast, right? So this is a nice little tool here. So for example, if you want something that is thinking a lot, has pretty high, right, pretty decent, I would say, context window, and also standard output length, and maybe has sub agents and something, right? You can say, let me just take a look how much it's going to cost, right? And so if you look at it, oh, is it this one? Hold on just a moment. Is it maybe that's the other one? It doesn't seem to be working now. Oh, this is a different one. Hold on, just a moment. Oh, where was it? Damn it. Of course, I will never be able to find it now anymore. But there was a little tool that allows you to actually track how expensive this would be for different type of system. Now that's a different thing, I'm afraid, here. And I'm just saying, I just want to point out that, of course, Chinese models are much, 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 much cheaper. However, there is also a conversation now that Chinese models might be cut off, so you might not be able to use them. So maybe if you're planning or thinking or considering doing something on premises for security reasons, and to reduce dependency on Anthropic and OpenAI and Meta, then you might want to get them now, maybe before they disappear altogether. Here we go. Yes, so David, you're probably right on this as well. Okay. Interesting. My observation is that Claude works much better when making from prompt to code, but trying to make it analyze provided figure. Oh yeah, that's right. This is very common observation actually. That's what a lot of people are observing. So moving from design to code is really bad because most AI does not have a good visual recognition patterns, right? So because it's been trained on text, so it's not very surprising, right? So it's probably best to move the other way around. The only thing you can do is to say, well, I want to produce something based on the design system, and these are the tokens you should be using, not just giving it a mock-up, but really more an representation about what you have in mind and ask it to produce it. right? I mean, you can also use Figma MCP and try to make things work with Figma, Claude, and so, but it's still, yeah, not great. Maybe, maybe it's going to change soon. Isn't it possible to design in code? I mean, that also is possible. I mean, we're at this point looking at a lot of different tools that allow you to do that. Of course, I don't remember how they're all called, but there are quite a few tools that basically try to move a bit more towards code, a bit less towards design, or the opposite side. That's happening too. Um, but I think that it just depends on not just the tool, but on what exactly you are supplying AI with. So most design systems just comprehensive but incomplete, right? And you can never make a design system complete because they will always have snowflake scenarios and all of, things like that. So it's always a bit tricky, I would say. At this point, we haven't resolved it for sure. Which AI works best to find out which your next workshop match best for me? Or you can always ask me. You don't need to ask AI for that, I think. If anything, I spent a lot of time on the legacy one. So legacy is no fun, and I think there is nothing I could find on legacy, like from the UX perspective, right? To modernize legacy from the UX side of things. So for me personally, and sorry that I'm bragging, but I really don't mean to do that. This is the first time I'm running this, but I think of all the different things, this is probably the most important one. I learned a lot preparing this. Also, I think one more important thing that's worth noting. Some people would say, um, uh, some people would say, well, but if you think about the AI models, they're not really getting much better, right? The reason why they say that is because as of now, there is a significant difference between two universes that are wide apart. There are people who are using a free version of Claude, free version of ChatGPT, free version of Gemini, free version of everything, right? And there are people who are paying $20, and there are people who are paying $200 or even more. There are significant, I mean, remarkable differences between them. So if your company is paying, right, and they pay two, three, $4,000 for you for tokens, right, you will have remarkable frontier models that nobody will get in regular world, right? Because most people don't want to pay $1,000 for a model. That's just too much. So if you are privately, right, paying $200 for something, you are universe away from people who are paying nothing. Because free tier models, they're usually quite outdated for good reasons. Why would you even burn money on them? Because you're not making money anyway, right? So what happens is you get free models on free tier models, which are early 2025-ish, and they're just not great compared to what we can do today, right? But if you're paying $20, like for example in Claude right now, you get this Fable, and Fable is quite fabulous, I have to say. So I automate quite a lot of things in my life just by paying $20 to Claude, to Anthropic, right? But a lot of people don't. And so you get significantly different experience for free tier versus paid tier versus really ultra paid tier, right? So that's just something to keep in mind. So when people speak about, well, I don't see any improvement in AI, that depends on how they use AI. Risha is wondering how to stay relevant in the AI era. I just pay attention to what is relevant to me. So whenever I have, let's say, some problems that I try to fix, I always think about creative ways of doing it. And I'm just following a couple of people on LinkedIn, and that's it. I mean, I subscribe to all these AI newsletters and I never read them, ever. Just too much. In fact, what I do subscribe to is Ethan Holick on LinkedIn. So just post a lot about, is it this one? I think it's not. Hold on. Molick. Ooh, sorry about that, Ethan. So he probably reads every single research paper, so I don't have to be following anything that he has here. That's quite impressive, like all the insights. And if you want to stay up to date, this is there. But then there is also Romina. So if you're looking more into agentic design systems, Romina is really great. And she's writing quite a bit of stuff on that here. And then there is a few more people, just a second, just to give you a clue. that I really appreciate because they share a lot. Let's see. There is Louisa. Oh, Louisa is so good also. So I highly recommend you also to look up Louisa. She's writing quite a lot and spending a lot of time on it too. Beyond that, if you're looking more on AI PM kind of side of things, so AI for product managers, I can also highly recommend to you Pavel. And these are the only four sources I'm following most of the time. I mean, that's already enough, I would say. Yep, for sure. So Jose has into design systems as well. SIT is also great. How do you keep up with how fast things change while still being productive? Frankly, I'm just focusing on being productive. I'm not trying to stay up to date. If something happens, it kind of finds a way to find me, I guess. And if I'm a little bit behind, that's not a problem, I think. I'm not sure I need to be like on top of those things. What I'm more possessed by is automating everything that I really dislike in my life, like all the boring parts, and really keep it like the fun parts for myself. There is a very strong desire to automate everything. I mean, why would you automate things that you like? I just don't get it. I don't understand it. So I automate everything I don't like, all the forms I have to fill in. Like for example, for one of the projects I have right now, I had to fill in this really strange, I think it's called F40 form in India. That's no fun. I mean, that's no fun. So instead I said, hey, Claude, so here are all the data that you need to know. Here's all the data you need to know about. I'm not giving you my kind of company name on everything, but the other things that might be relevant for you to know. Just knock yourself out. Just try to complete it to the best of your ability. And it did so well. I was so impressed. So I just added the name and the company and stuff, and that was it. And also, just to maybe make it very clear here, there's one example I want to show, which I was really impressed by. Oh, this is the world. This is very exciting, I think. Let me show you. I think it's not here. Just a moment. Please don't run away. Now that you will never forget. This is where I think the value actually lives. So let's see. It's going to be here. Here. Yes, here we go. So what I wanted to show you is this. Now this is Legora. Legora is an application that is used, oh, this is maybe for week, for lawyers who are dealing with legal documents and they need to work through them. If you get things right without hallucinations in Legora, in the legal document, then you're probably going to be in a good place. Now, for example, in Legora, you can do this because it's deeply integrated in Microsoft Word and in Apple Pages and all of
So
that.
what I will do is I will pick the reference document, which in this case is the chamber submission, and I will then run the fill template action. And that's it. Legora will take the content from the chambers document and produce edits for me that I can use to fill in the relevant sections in the legal 500 document.
That's all. I cried when I saw this. Because this is the type of work that I absolutely hate, right? Why should I be doing this? Shouldn't AI do this? And so it does. And so I'm really more excited not about the assistance or anything like that, but I'm very excited about deep integrations. So this is so good. So I want AI to be integrated in where the work actually happens in Excel, which it already is, in Outlook, where it already is, in Apple Mail, where it already is, right? In, Docs, PDF, anywhere, right? That's where you actually save a remarkable amount of time, right? So I'm very excited about this personally. By the way, if you're just looking into this, and if you happen to be a lawyer or so, this is quite fascinating stuff. This Legora is a remarkable AI product. It's probably the best AI product I know. It presents itself a little bit too fancy, maybe, and it's so good. So good. I mean, I'm not a lawyer, so it's not really for me, right? But maybe that would be helpful for you. But yes, I think if you're actually looking for Legora AI verse, you'll find it. This is this interaction here. Ooh, it was. Hold on, Legora. Yep, that's the one. Here we go.
So what I will do is I will pick
Right. And also, just in case you're looking for design patterns for AI, I obviously put together quite a few things here as well in our Google Doc somewhere. I don't have this Google Doc anymore. So it was smashed by complex AI complex or something, was it? Smashed by complex. Right. So there are quite a few different tools, products for, I have to clean it up, I think. At this point, I noticed this. Here we go. These are, if you look at them, these are all the little galleries of AI design patterns. So maybe you'll find that here useful as well. And also for audio, by the way. This is fun. Right. Excellent. Well, thank you so much for joining, everyone. I hope this was worth your time. Feel free to send me an email. There is also stuff here at the bottom. You can also send me an email if you're interested, if you want to work together or something. There are video courses, and there are also the courses here on Smashing and also the on Maven. So you'll be also getting a recording email by email. So watch out for that. And hopefully see you next time.